This paper introduces a novel approach that integrates cognitive AI and generative AI to enhance question answering in skill-based learning. It leverages a structured knowledge representation framework called TMK, Task Method Knowledge, to encode skills taught in an online knowledge-based AI course. The TMK model decomposes problem-solving skills into three components: task, method, and knowledge, representing skills as abstract devices that can be introspected for generating explanations to user questions. The authors propose two research questions and hypotheses to explore the convergence of cognitive AI and generative AI for skill-based learning. They review related work on representing skills in AI and generating answers using AI, highlighting the importance of representing skills as abstract devices, and the potential of leveraging cognitive AI and generative AI methods for various use cases. Ivy, an interactive video system, draws inspiration from cognitive science theory to answer questions. It classifies user questions as either related to semantic knowledge or episodic knowledge using a large language model, LLM, based on GPT 3.5 Turbo. This paper focuses on questions related to semantic knowledge. Ivy's functionality is guided by the TMK model, which involves task definition, method specification, and knowledge representation. Once a question has been categorized as pertaining to semantic knowledge, Ivy further classifies it based on the components of the TMK model, distinguishing between knowledge model, method, task model, and multi-model questions. Ivy then retrieves the most relevant documents from the TMK knowledge base, involving two key steps: K-score calculation and document retrieval. The K-score, ranging from 1 to 4, determines the level of detail and complexity in the response. Finally, Ivy generates a response based on the classification of the question and the retrieved documents, employing an iterative refinement process for knowledge model or multi-model questions. Ivy, a cognitive AI system, leverages a hybrid approach combining task method knowledge, TMK, modeling with generative AI techniques to enhance question answering in skill-based learning environments. The TMK model systematically encodes skills, providing a structured and detailed representation that supports accurate and contextually rich explanations. The system employs a chain-of-thought generation process for method, task model questions, extracting relevant transitions from the topmost method document to generate a natural language response that explains the task completion process. The system's iterative refinement process uses a large language model, LLM, to synthesize information from documents, refining the initial response to generate a more comprehensive answer. Evaluation metrics, including completeness, precision, and consistency, assess the system's ability to provide accurate and relevant information. The system's ability to generate detailed explanations of the problem-solving process is also demonstrated, allowing it to answer what if and how questions. The proposed system has the potential to bridge the gap between passive content consumption and active learning engagement, simulating a deeper understanding and providing interactive feedback to learners. The TMK framework also holds potential for expanding into episodic knowledge question answering. Future work includes refining and standardizing the evaluation mechanism, automating the creation of TMK models, and enhancing the integration of chain-of-thought and iterative refinement techniques. The authors acknowledge the importance of abstraction in data-sparse task transfer and the use of ontology-based knowledge representation for increased skill reusability in industrial robots. The proposed system aims to provide a robust and scalable approach to task modeling and knowledge representation, with a focus on improving the evaluation mechanism and integrating advanced techniques for generative AI. This research integrates concepts from knowledge-based question answering, episodic and semantic memory, and language models to propose a novel approach to question answering. Episodic and semantic memory are interdependent, as shown by neuropsychological studies, and both are encompassed by declarative memory. Inspired by the few-shot learning capabilities of language models, the authors develop a framework leveraging the FAISS library for efficient similarity search and introduce a ranking-based method that iteratively refines answers by re-ranking knowledge base entities. The framework comprises a knowledge base encoder, question encoder, and ranking module. The knowledge base encoder utilizes a transformer-based architecture to generate entity representations, while the question encoder employs a similar architecture to produce question representations. The ranking module computes the similarity between question and entity representations, generating a ranked list of answers. The approach is augmented with generation capabilities, enabling the model to produce answers not present in the knowledge base. The authors evaluate their approach on benchmark datasets, achieving state-of-the-art results, and conduct ablation studies to investigate the impact of various components on performance. The limitations of the approach are acknowledged, including reliance on pre-trained language models and the need for further research on incorporating episodic memory. Future work directions include exploring alternative episodic memory models and integrating them into the proposed framework. The author's work highlights the potential of leveraging episodic memory in question-answering systems, drawing parallels with human memory retrieval processes. Key equations and algorithms are presented in the framework, including the ranking-based method and the transformer-based architectures. The authors also discuss the importance of similarity search and the role of the FAISS library in efficient similarity computation. The evaluation results are presented in tables and graphs, demonstrating the effectiveness of the approach.